I'm going to present the Cloud Edge platform for hyperspectral image developed in the multiple projects. The platform has two main parts. It consists of, on one hand, on edge devices that work in the factory floor. These devices are in charge of the acquisition of hyperspectral image data, and also of all the real-time operations that are required in the factory floor. And on the other hand, the other component of the platform is the cloud platform that is in charge of the ingest and curation of hyperspectral images, and the creation, the extraction of features, and the creation of data sets, and which is the main goal of the whole platform. It enables the prototyping of classification and segmentation models. Well, the edge devices are from a hardware viewpoint are basically a system of module based on ARM processors and powered with GPU units that enable the use of machine learning models at the speed. These devices have a software that has been developed in multiple for the acquisition of hyperspectral images, which includes not only the image acquisition, but also the reconstruction of hyperspectral data cubes. And the edge devices are also in charge of all the real-time operations, which are basically of two types: the running of machine learning models, for instance, for defect detection and classification in a boot working scenario, or for process monitoring in a chocolate production line. As well, the embedded devices are in charge of, should take all the real-time decisions, like that are related to process control, like the rejection of defective parts, or decisions on the timing of the process, like proceeding to the next stage of the process. Finally, the devices are capable to connect to the cloud for the ingest of data, but also for the update of the machine learning models that they are running. Well, here we can see an example of an edge device working in a boot working production line. We see the boot panels going through the line, and here we are starting the edge device that acquires the image and also reconstructs the hyperspectral data cubes. Okay, and the next part of the platform is the cloud part, which it has itself two main components. On one hand, we have the warehouse, which provides a scalable solution for the ingest of hyperspectral images and all the related metadata, and it also supports the exploration and visualization of this data. For this purpose, we have developed a Python API that that supports searching by date, searching by category, like for instance defect, searching for a given defect, but also allows specific operations that are needed for hyperspectral images for their manipulation and visualization. We can visualize the specific spectral bands, and we can also perform some analysis of this, manual analysis of this image, like for instance, principal components analysis, and visualize all this printable spectral components, like in the figure shown. And the purpose, the ultimate purpose of the cloud platform is to facilitate the prototyping and deployment of machine learning models. For this purpose, we have, with this goal in mind, we have designed the Python API to minimize coding and to be notebook friendly. And we have pursued these two goals while covering all the essential steps to train, validate, and deploy a machine learning model. Next, we are going to see an example. Instead of seeing the video, I'm going to show how this is how an example of notebook looks. In this case, we are going to work with a small data set of just 18 images, which is suitable for a feasibility study. It's from a chocolate gloss classification application. So we after setting and launching the API client, we can select a data set. We look to the data set that we have. We select this one. And yeah, we tell the system to load the data set. And now we have loaded the data set. We create, since we have very few images, just 18 images, we are going to create 18 data splits to perform and leave one out training and validation. We have to select first the model that we want to train. We have different options. We are not going to use a deep model because we have very few images. So we're going to use a sport vector machine fed with local binary patterns. We have to create a model, and then we perform the training on the validation of these 18 gloss models. It's one training for each of the data splits created. Okay, so we are training 18 different models, and we are accumulating the results that we can look here, the accumulated results. We can see in this confusion matrix that the performance for a first try with a very simple model and very few images is not that bad. So the application looks feasible. And well, what we can do now is, of course, this model is not suitable for production yet, but we can test but if it were, deploying the model is very simple. We have the last of these 18 models is stored in this variable, so we can save it to the cloud. We have to choose one name, for instance. Yeah. For instance, my new gloss model. We can save the model, and then now the model is in the cloud. And the idea is that we can go to another machine, like for instance an embedded device. Here I'm going to make the demonstration with a different notebook, which is a different machine that also connects to the cloud. And yeah, we have to tell the machine where to look for models. We choose the same data set that we have used to train our model, and then we have to choose a model. I have different models here stored, and this is the one I just save my new GLOS model. So we choose this model and we load it from the cloud. Okay, the model is loaded, and now we can use it with image that, if this were an embedded device, it would be acquiring image, but we can feed in this notebook, we can feed the model with image that we have stored in the cloud. So we are going to use this image, for instance. Okay, well, here there is an error in the model, and here we have a good decision. Okay, so basically we have deployed a model, trained it in the cloud to a different machine, and with a very simple workflow from Immutable. We facilitate the prototyping and deployment of machine learning models tailored to a hyperspectral image. And the approach adopted is also specially thought with a typical engineering team in mind, working in a production line setting.